Today we are going to be looking at an MAT question asking about the behavior of this long, rather ugly looking expression as x gets very large. Now it's quite difficult to know how to approach this problem, but we can look at the possible options for inspiration, and in particular, these three, very close to zero, equal to one, and very large are quite important. Now that's because if we think about a to the x for some positive a to the x isn't always going to be defined for negative a. For example, minus 1 to the half would be the square root of minus 1, which as far as we're concerned doesn't exist. But if we imagine that a is positive, then as x gets really large, there's three cases. If a is greater than 1, then as x gets bigger, this is going to blow up. A to the x is going to get very large. So that would correspond to option E. Now, if a itself is equal to 1, then 1 to the x is always going to be 1. So that would correspond to option C. And finally, if a was less than 1, but of course we want it to be positive or at least greater than or equal to 0, then this is either going to be equal to 0 or very close to 0. So that's going to correspond to option A. Now, this is helpful because we can notice that this expression contains a lot of powers of x. In fact, we can even write it as one big power of x. So if we use our laws of indices and take the power of x out, we're going to get 2 times 3 to the minus 1 times 4 times 5 to the minus 1, and so on, all the way up to 20 times 21 to the minus 1. And that's all going to be to the power of x. So what we really need to figure out is which of these cases we're in. Is this number in the middle here, which we can call a, greater than 1, equal to 1, or between 0 and 1? Now, there's a quite clever trick we can use here, which is to actually pair these numbers up. If we imagine pairing this even number with the next slightly larger odd number, then we can continue doing this. We haven't written out all of the numbers, but we know that some even number is going to be paired with the next larger odd number. So the pairing is going to end in 20 paired with 21. We haven't skipped something in the middle. And if we look inside each of these brackets, we're actually going to get an expression which is less than 1, right? So for example, this is equal to 2 over 3, and that is indeed between 1 and 0. Similarly, this is equal to 4 over 5, and that's between 1 and 0. So when we multiply all of these together, we're also going to get a number, and that's between 1 and 0, which means that this a over here, the product, is itself going to be between 0 and 1. And that means that when we take it to a really large power of x, it's going to start getting very small. And so we can conclude that the answer is option A. I hope you enjoyed this problem. Thank you so much for watching, and I'll catch you all in the next one.